Before we plunge into the assertion, it is vital to initially comprehend what molecule gas petals are. The monstrous Hadron Collider, LHC, worked by CERN, is a 17 ring of superconducting magnets. It is the world's biggest and most impressive molecule smasher, addressing the pinnacle of human logical accomplishment. As a matter of fact, it's so powerful that it could reproduce the states of the primary snapshots of the universe. But might this machine at any point plan to uncover the mysteries of the universe or hold the way to something substantially more? CERN, established in 1954, is one of the world's most eminent exploration associations. With 23 member states and countless researchers, it is a center for collaboration and advancement. The LHC is CERN's flagship project, yet it is only one piece of a huge organization of molecule gas petals and examinations. Envision a course not for vehicles or planes, but rather for subatomic particles in a trial of mastery, steadiness, and, surprisingly, the texture of space itself. The LHC speeds up protons to nearly the speed of light, sending them on an impact course that imitates the energy of the universe at the moment of the Big Bang. The impacts create temperatures many times hotter than the core of the Sun. A variety of magnets guides the protons on their journey, while complex cooling frameworks maintain temperatures colder than space. The beams inside the LHC are designed to crash at 4 locations around the gas petal ring, corresponding to the positions of 4 molecule detectors: Atlas, CMS, ALICE, and LHCb. Each detector has a unique purpose, investigating various aspects of particle physics. Together, these detectors act as giant cameras, capturing images of these crashes. Specialists then sift through the debris, searching for signs of the elusive Higgs boson, otherwise known as the God particle, and other anomalies that may reveal the universe's fundamental structure. By focusing on the microcosm, we gain insights into the macrocosm. However, with each answer comes another question, and with every discovery, a new challenge arises. The LHC isn't just a scientific instrument. It is a demonstration of human curiosity and progress. It embodies our persistent drive for knowledge and our desire to understand the fundamental forces that shape the universe. Yet, as we push the boundaries of what we know, we must also consider the ethical and existential questions that arise. What are the risks of exploring the unknown? Could our quest for understanding inadvertently unleash forces beyond our control? In the hallowed halls of CERN, where the limits of human knowledge are continually tested, a discovery has emerged that has left even the most prepared scientists uneasy. Brian Cox, a former scientist at CERN and an expert in particle physics, recently made a statement that both impressed and unsettled the world. His words resonate with chilling clarity. The goal of CERN's Large Hadron Collider is to recreate a miniature Big Bang. Yes, you heard that right, a small version of the very event that birthed our universe. Cox also discussed the implications of this goal, highlighting the LHC's extraordinary potential for groundbreaking discoveries, such as unlocking the secrets of the Higgs boson and exploring dark matter, a mysterious substance that constitutes much of the universe. Imagine grasping the power of creation, the ability to summon the very essence of the universe. It's an alluring prospect, but one fraught with risk. The miniature Big Bang is not a speculative concept. It is a tangible reality within the LHC. The temperatures, pressures, and raw energy within the LHC replicate the conditions that existed at the birth of the universe. It is like standing at the dawn of history, witnessing the birth of existence itself. However, with such power comes enormous responsibility, and the question remains, what if something goes wrong? In fact, something did go wrong back in 1978. Russian physicist Anatoly Bugorsky experienced a catastrophe that would forever alter the course of his life. While working on the UB-70 synchrotron at the Institute for High-Energy Physics in Protvino, Russia, a discharge failure caused a proton beam to strike him directly. The beam passed through his skull, entering the back of his head and exiting through his nose. Despite the horrific injury, Bugorsky remained conscious, even walking to a treatment center. His intellectual faculties remained intact, but the beam caused localized tissue damage, leading to hearing loss in one ear and partial facial paralysis. This incident serves as a stark reminder of the immense power and potential dangers of particle accelerators. The risks associated with a particle smasher like the LHC are not to be underestimated. The potential for unexpected reactions and for altering the very fabric of existence are the stuff of science fiction, as well as real concerns voiced by respected scientists. One of the most troubling and fascinating concerns related to the LHC's experiments is the possibility of creating a miniature black hole. Black holes are regions of spacetime where gravity is so intense that nothing, not even light, can escape. These cosmic entities are vacuum cleaners devouring stars and mysterious forces lurking in the depths of the universe. That the LHC might potentially create such a substance, even on a small scale, is staggering to both the public and scientists alike. Could this black hole grow uncontrollably, eventually consuming the Earth from within? Scientists at CERN have assured the public that any black hole created would be unstable and would vanish quickly. Nonetheless, this remote possibility has sparked fear, speculation, and awe at the power we wield. Understanding how the LHC could create a black hole involves the basic principles of particle accelerators. When protons collide at nearly the speed of light, the energy released is so immense that it bends the fabric of spacetime itself. Consider a trampoline stretched tight, then dropping a heavy object onto it. The fabric bends, and if the object is heavy enough, it could create a depression so deep that anything nearby would be pulled into it. This is a simplified analogy for what could happen at the LHC, where, in the realm of quantum physics, the laws of the universe behave in strange and wondrous ways. There is a theory that extra dimensions may exist within our reality, hidden from view. If these dimensions exist, the LHC's experiments could tap into them, creating a gravitational well that forms a tiny black hole. This peculiar behavior has caught the attention of several prominent scientists, including the late Stephen Hawking. In his writings, he warned that the Higgs boson could become unstable at extremely high energy levels, leading to catastrophic vacuum decay, an event that wouldn't just destroy the Earth but could potentially annihilate the entire universe. Sir Martin Rees, a renowned British cosmologist and astrophysicist, also expressed concerns about experiments at CERN. In his book Exploring the Future of Humanity, his words were not cautious. They were filled with existential dread. He described a worst-case scenario where a failed experiment could create vacuum instability, triggering a phase change that would ripple through spacetime, potentially engulfing the entire universe. Rees assigned a low probability to these catastrophic outcomes, but he argued that even a small chance should be taken seriously. The stakes are extremely high, and the margin for error is razor-thin. Some have conjectured that the LHC's examinations could open an entrance to one more universe or aspect. While this thought is generally excused by standard researchers, it has captured the public's imagination and become the subject of dread, legend, and fascination. What could lie beyond our universe? Might we accidentally unleash powers or substances that we don't fully understand? The idea of opening an entryway to damnation has been sensationalized in the media, further fueling uncertainty. But how did this idea emerge, and what does it mean in terms of scientific exploration? The concept of additional dimensions isn't new in physics. String theory, a leading contender for a unified theory of everything, suggests that there may be more dimensions beyond the usual three of space and one of time. These additional dimensions could be compactified or hidden from our perception but could theoretically be accessed under extreme conditions. Imagine the LHC as a cosmic key, opening doors that have been sealed since the earliest days of recorded history. When protons collide with energies never before achieved on Earth, they could create ripples that test these hidden dimensions. If these dimensions exist, the LHC could reveal them. However, it is vital to note that, while the LHC is undeniably powerful, there is no definitive evidence to suggest it will open a portal to another universe, let alone to hell itself. Nevertheless, the allure of the unknown, combined with the mysterious nature of quantum physics, continues to captivate the public's imagination. So, should we be worried about the LHC and its potential dangers? It's easy to be swept away by sensational headlines and fears of global disaster. However, the truth is that the scientists at CERN are highly aware of the risks involved. They have taken every precaution to ensure that their experiments are safe and continue to monitor and assess their work with the highest level of diligence. The potential benefits of their research, breakthroughs in our understanding of the universe, the discovery of new particles, and the exploration of dark matter, are extraordinary. This isn't just a display of human ingenuity but a window into the very heart of the universe. However, like any great leap forward in science, it comes with its risks. We should approach it with a balance of wonder, respect, and caution. The Large Hadron Collider represents the cutting edge of scientific inquiry, where theoretical physics meets experimental reality. Its potential to answer fundamental questions about the universe, such as the origins of mass and the nature of dark matter, is unparalleled. Despite rigorous safety measures and detailed calculations, the LHC still evokes a sense of mystery and fear among some. The sheer scale of the machine and the energy it produces are awe-inspiring, and each new experiment opens the door to uncharted scientific territory. While most scientists remain confident in the safety of the LHC's operations, uncertainties still exist. What if new, unexpected anomalies arise that challenge our understanding of physics and the laws of the universe? The LHC pushes the boundaries of human knowledge and tests the limits of our control over nature. As particle collisions recreate conditions unseen since the Big Bang, the significance of these experiments raises existential questions about the potential consequences of altering the very fabric of the universe. Nevertheless, the LHC's achievements in particle physics have been groundbreaking. It has led to the discovery of the Higgs boson, advanced our understanding of the Standard Model, and opened pathways to potential breakthroughs that may one day shape our technological future. Despite the risks, the pursuit of knowledge remains one of humanity's most ambitious endeavors. The journey of scientific discovery is rarely without risk, and the LHC is no exception. Its experiments explore the frontiers of physics, where intuition no longer applies. For centuries, physicists have tried to understand the fundamental forces of nature: gravity, electromagnetism, the weak nuclear force, and the strong nuclear force, all of which play a critical role in the formation of matter. The LHC stands as a testament to human ingenuity and curiosity, driving forward the quest for knowledge in ways once unimaginable. It is not just a tool for scientific exploration but a beacon of collaboration, bringing together the brightest minds from around the globe to unravel the mysteries of the universe. At the heart of the LHC's mission is the quest for answers to questions that have captivated humanity for millennia. What are the fundamental forces that govern our reality? What are the true building blocks of matter? How did the universe come to be as it is today? While the LHC has already achieved remarkable accomplishments, such as confirming the existence of the Higgs boson in 2012, it continues to push the boundaries of our knowledge. Every proton collision within the collider carries the potential for discovery, from new particles to previously unnoticed phenomena. Yet, with such power and potential for discovery comes the responsibility to exercise caution. Scientists, though confident in their safety measures, remain ever mindful of the risks, both known and unknown, that come with testing at the very frontiers of physics. Harnessing the forces that shape the universe, or even creating phenomena like miniature black holes, naturally raises concerns. It is a reminder that scientific progress is not without its dangers. Despite the strict safety protocols in place, the stakes are immense, and every experiment carries with it a measure of uncertainty. Theoretical physicists such as Stephen Hawking warned of the potential for catastrophic events, such as vacuum instability or destructive vacuum decay, which could theoretically lead to irreversible consequences. While the likelihood of such events is low, their very possibility sparks public fear and intrigue. For some, the LHC is a symbol of humanity's relentless drive to master nature, a desire to harness and control the forces that govern the universe. For others, it is a tool of enlightenment, a pathway to understanding the fundamental nature of reality itself. The pursuit of knowledge, however, is not without consequences. As with all scientific endeavors, the path to discovery is fraught with ethical dilemmas and unforeseen risks. What happens when the power to explore the universe's deepest secrets falls into human hands? Should we, in our quest for knowledge, pause to consider whether we are ready for the answers we might find? The idea of opening doors to other dimensions, or even other universes, though largely speculative, feeds into our collective imagination. It's easy to see how the combination of unprecedented scientific progress and profound existential questions could give rise to fears of unforeseen side effects. It is a delicate balance between discovery and caution, a tightrope that has defined humanity's journey through the scientific revolution and beyond. At the core of these concerns lies a deeper question. How far are we willing to go in the name of progress, and what are we prepared to risk in our pursuit of the unknown? In the end, the LHC is more than just a machine. It is a reflection of humanity's insatiable curiosity, our desire to understand the universe in its most fundamental form. It is a symbol of both our greatness and our vulnerability. While we may never have all the answers, the questions that the LHC raises are fundamental to our understanding of the universe. Even as we push the boundaries of what is possible, we must remember that every discovery opens up new avenues of inquiry, new challenges, and new opportunities for exploration. Whether it ultimately proves to be a gateway to a deeper understanding of the universe or a harbinger of unintended consequences, the LHC's legacy will undoubtedly shape the course of scientific inquiry for generations to come. The pursuit of knowledge is a powerful force. As we continue to explore the mysteries of the universe, we must proceed with care, mindful of both the promises and the perils that lie ahead.